Welcome to RSET Online. In today's class, we will see aircraft anatomy and different types of aircraft wings. Now, the important parts of an aircraft are wing, fuselage, rudder, then next comes landing gear, most importantly the power plant. In the last sessions we saw about jet engines, the power plants used to power the flight. Okay, then then comes elevators, which is used to control the angle of attack of the main wing. You can see a small wing towards the back side of the plane near the tail. That's called elevator. And connected to elevator is horizontal stabilizer. That in fact stabilizes the aircraft in horizontal direction. Okay. Now, before moving into the details of aircraft anatomy, we will see typically the motion exhibited by aircrafts. Okay. Now, looking into the figure, you can see the horizontal motion, horizontal rotation in the Z axis is called yaw. Again, you can see the motion around y axis, which is referred to as pitch. Typically, pitch is associated with angle of attack. And you can see the plane can also rotate in x axis, leading to the motion called roll. Roll is exhibited while taking a direction change, and pitch is exhibited while takeoff and landing, because the angle of attack changes while takeoff and landing time. Okay. Now yaw is also exhibited when aircraft makes direction changes. So this in this figure you can see there is two rotational degrees of freedom in three axes. That means clockwise and anti-clockwise. So altogether 6 rotational degrees of freedom and 1 translational degrees of freedom. So totally aircraft has 7 degrees of freedom when it flies through a 3D space. Okay. Now, the purpose of ailerons is to assist the aircraft in making turns. Okay, along with a rudder. Now, flaps are used for increasing the lift at lower speeds. Now, you can see other parts like elevators, which, as I told you before, is used for controlling the angle of attack or pitch of the aircraft. And when ailerons are opposited in opposite direction, that typically creates a roll motion for the aircraft. You could see in air shows that military aircrafts are performing aerobatics, like turning the aircraft, rotating it in full 360 degrees and performing aerobatics. Okay. Now, the same is the case with horizontal stabilizer or the tail plane and elevators. Uh, you can also see the passenger aircrafts in a vertical takeoff mode at low loads, in complete vertical takeoff mode. Okay. So when the plane is fully loaded, it will not go into a vertical takeoff mode, especially in the case of passenger jets, whereas military aircrafts are designed for performing various kinds of flight performances like vertical takeoff or high stalling recovery, like that, because this is essential when intercepting with enemy aircrafts during wartime. Okay, with this I come to an end to the anatomy of aircraft. We will see more details of each sections as we progress throughout the syllabus, and right now I am planning to take the case, or we will study more details about the wings of the aircrafts. Okay. Now, when it comes to aircraft wings, this has been a subject which has been in active research for at least past 150 years. The reason why Wright brothers were successful is that they came up with a better design for aircraft wings for the first time, and that's the reason why they were able to successfully fly the plane for 35 seconds, historical flight that happened in North Carolina. Now, after that onwards, this has been a subject of active research, and various designs are being experimented. The problem with aircraft wings is that not a single design can cater all the needs of the flight. For example, imagine the wings of supersonic aircrafts and subsonic aircrafts are different in geometry. Our objective in wing design is that it should reduce the drag, and it should create more lift. That is the objective. So, in order to meet this objective, uh, we have to choose different types of wing according to our needs. See, if you're flying a supersonic aircraft, you need to go for a delta configuration or a triangular kind of configurations. You can blend some part of the body into it and come up with a tapered configuration. Then, if it is subsonic cruising, uh, subsonic cruiser, the wing design, most commonly accepted wing design is tapered. Sorry, it's not tapered, it's swept wing design. The wing sections will have an angle as it move towards the end. So in shown in figure is a swept wing design for Boeing Dreamliner. This is very efficient for subsonic speeds. Now, shown in figure is a delta wing configuration, or more correctly, Ogave wing configurations. This wings are very efficient during supersonic flights, but gives poor performance during subsonic flights. Usually, for the passenger Concorde, they used to charge more if the flight happens to fly at subsonic speeds before landing into the airport based on the air traffics. Now the problem with the Ogave wing is that in terms of manufacturability, this is very difficult to manufacture. The cost incurred is very high. Then the problem is also there in terms of mounting the engines, mounting the fuel tanks, etc. etc. So, as I told you before, the most commonly accepted one for passenger segment is swept wing design, and now we will see variable type of wing designs. Okay. Now, as you can see in the figure, the sweep of the wing is adjusted by suitable mechanisms placed inside the fuselage of the aircraft. We do this to improve the performance of aircraft over a wide ranges, because, and mostly this is done with military aircrafts. As you know, during wartime, this is designed to intercept with enemy planes, different types of enemy planes. So naturally, this has to perform at various speed levels and various altitudes. Okay, from very high altitudes to very low altitudes. To meet these requirements, the design is now to change the geometry of the wing. This is one of the highly researched area today, and this can also make the aircraft more efficient while taking off from the ground, and at cruising speed it can bend inwards and make supersonic flights. So these flights are basically designed to perform very well on subsonic as well as supersonic speeds. That is the reason why we are going for a variable geometry type wings. But this facility is mostly available only with you know military aircrafts. It's not available in the passenger segment. And the problem with the passenger segment is that it needs to prove the reliability for at least 20 years. Only after then it will get certified or accepted into the passenger segments. To get a passenger segment certification for an aircraft design, it is very difficult. It has to prove itself for, I believe, something like a span of 15 to 30 years. And as I told you before, we have blended wing designs also, which is highly fuel efficient. But again, the problem, as discussed over the last classes, still it needs to prove in terms of structural reliability and things like controllability and stability of the aircraft. And we need computer hardware for flying such kind of blended wing body designs. Of course, if it happens to be introduced in the commercial segment, which I believe will be there available in the near future, that should definitely make our ticket cost at least 30% less as it is of today, because those designs are highly fuel efficient and easy to maintain also the aircrafts. So with this I covered two types of wing. One is delta type and the other one is swept wing. We have rectangular design, elliptical design. Elliptical design has not shown in the figure. Elliptical designs have the advantage of less drag and more lift according to the pressure profile. But again, that is only used in the military segment mostly. It has certain disadvantages when flying at subsonic cruising altitude. Now, with these few concepts, I am coming to an end. I am giving you two references. One is Quora, www.quora.com, and the other reference is aviationcompare.com. So, we'll see you on another occasions. Goodbye.